Good evening. Welcome from my home at Lucie in Sussex. And I'm going to talk about storms on other worlds. We get storms here, but also elsewhere. And there's one going on at the moment. The lovely ring planet Saturn is one of you, and so we'll start from there. Saturn is big, nearly 75,000 miles in diameter, far larger than the Earth. At the moment, a wild storm is raging there. Well, storms on other worlds can be really dramatic, and with me are two enthusiastic observers, Paul Abel and Chris North. Now, Saturn, interesting things are going on there.
Yes, I mean, Saturn's had this new storm that's been forming in its solar system. It's important to put it in context by talking about what Saturn is in the solar system. Saturn's one of the gas giants in the solar system, along with Jupiter, the largest planet, and further out Uranus and Neptune, which we call the ice giants. And then closer in, we've got the much more familiar planets, the Mercury, Venus, Earth and Mars, the rocky planets or terrestrial planets that tend to have much smaller atmospheres, if at all. But the gas giants have got this big, thick atmosphere, and they're predominantly atmosphere most of the way down, very different places.
What's happening on Saturn now?
Well, there's been this remarkable change, Paul. I mean, you've been looking at the storm in great detail.
I have been looking at the storm in great detail. Saturn has a history for storms, as you know.
Yeah, I do indeed.
It's not as active as Jupiter, because you've got that thick layer of chemical haze above it. But Saturn only springs us with storms every 13, 15, 30 years. The first ever really noticeable bright storm occurred way back in 1876, when on the 7th of December, Professor Asaph Hall discovered an intensely bright white oval in Saturn's north equatorial zone.
Then 1933, it was discovered by W.T. Hay.
Indeed. Well, one of the things that Asaph Hall and Will Hay have in common is not a lot was known about Saturn at the time, and they both used these spots to get an estimate of how quickly Saturn rotates. And of course, the one we have today was discovered back in December 2010. This is quite unusual. It didn't start off as a big bright oval in the equatorial zone. It's much further north and very intensely bright. And for all the world, to me, it looks like a bright comet.
Is it still there now?
It's still there now, still raging away. Very dynamic and changing constantly.
And growing. It's spreading around the planet.
I've never seen anything like it. What we think actually at the moment is the bright storm on Saturn that's raging away. We think those are water ice crystals high up in the atmosphere, and that's the reason why it's so incredibly bright. These water ice crystals reflecting the sunlight. Quite pretty.
We have this major storm on Saturn now, but what causes it?
Well, the storms are generally caused by winds and the way that the atmospheres are moving around. And on Earth, we're used to weather systems. We have a global weather system on Earth. We obviously have clouds that now and again rain, but in global terms, we have things that we call the jet stream and so on. And what drives them is the rotation of Earth, combined with the fact that only ever one half of it is lit by the sun, and that heating is greater near the equator than at the poles, and you get this flow of air. And we see similar things on the other planets, that the way the atmosphere moves is driven by the solar heating from the sun combined with the rotation of the planet. And they all rotate, a lot of them, incredibly quickly compared to the Earth. I mean, Jupiter's 10 hours.
But not in the same way, though. The equators rotate quicker than the top and bottom halves, which is why we have these sort of strange systems of longitude, quite different from here. Of course, one of the things that's noticeably different is the longevity of storms on Jupiter and Saturn. And this is simply because there's no land there to dissipate the storms as we get here on Earth.
If you think about hurricanes on Earth, then they form over the ocean, and as soon as they make landfall, they dissipate and they fairly quickly disappear. And with no solid surface on these planets, then that simply doesn't happen, and they carry on. I mean, in terms of the Great Red Spot, which is, I would argue, the most famous storm in the solar system on the planet Jupiter, I mean, that we think has been going for centuries. I mean,
well, there's some debate as to whether it's been going for centuries. Some ideas is maybe that it contracts down and vanishes and a new one appears, because obviously Jupiter's not unknown for producing new red spots. Or it is the same one that contracts and expands. Nobody really knows.
What about the hexagon on Saturn?
Yes, that is a very unusual thing. First recorded by Voyager 2 when it got to Saturn in '81. Seen since again by Cassini. But you found earlier this has actually been simulated in the lab, hasn't it?
Yeah, they tried to recreate this very bizarre feature. So the feature is this hexagon shape when we're looking on the northern pole of Saturn. when we look in the infrared with Cassini, we can see the other features, the other clouds in the atmosphere moving around, but this hexagon feature stays there. Now, the lab experiments have tried to recreate this by creating a tank of water spinning at different speeds in the inside to the outside. And if you get the relative speeds, the middle and the outside, roughly right, then you do get these shapes forming that stay there. So you can form a hexagon if you get the speeds at one ratio. If you get them slightly different, you might form a heptagon, a seven-sided shape. Yeah. If they're slightly different again, you could even, if you wanted, form a triangle. And that also can explain things like the ovals we see. So it could just be a coincidence with the way the wind speeds are working near the pole of Saturn, and it could be something that lasts for a few decades. We don't know. We haven't.
It's certainly been there for a while.
Yeah,
since
Voyager 2. Yeah. It's quite hard for us to observe the pole of Saturn well from Earth.
It is,
We see it at a very oblique angle. Certainly something that Cassini will no doubt be continuing to look at while it's there.
The thing to get across is really just how big these storms are. I mean, you remember the Selzy tornado.
I do indeed.
That is insignificant compared to
Didn't see it at the time.
No, but compared to the storms on Jupiter and Saturn, they are ineffectual. The storms on Jupiter and Saturn are very powerful. The wind speeds, in particular on Jupiter and Saturn, are very, very, very high. And out to Neptune. I think Neptune has the highest, doesn't it?
Yes, the highest recorded speeds on Neptune are over 1,000 miles an hour. I mean, they're staggering.
Enormously
staggering
powerful. The Great Red Spot, of course, many times larger than the Earth. The storm that's currently raging in Saturn's northern hemisphere, that's larger than the Earth. All of these storms on Saturn, Jupiter, and on Neptune are planet-sized, Earth-sized. It's remarkable.
If we flew the Earth to Jupiter, which would be fun, then you could fit it 2 or 3 times into the Great Red Spot. Yeah. Interesting experiment.
Chris, Paul, thank you very much. Now, in my garden, Pete Lawrence has my 15-inch reflector, I hope, trained towards Saturn.
Knock, knock.
Hello, Paul.
How are you doing? Oh, you've got Saturn.
Yeah, not too bad. It's been a bit of a struggle tonight, I have to say, because the atmosphere is actually quite turbulent.
Yes, it is. Look, that's quite poor seeing.
In fact, there's a saying, isn't there, with planets, that if you look at them with the naked eye, then stars twinkle, but planets don't twinkle.
No.
Well, tonight I went out and I looked at Saturn, and it was twinkling. That shows how bad everything is up there.
Do you know what Patrick calls that?
What's that?
Jellyfish seeing.
Well, that's a very good description, but it's actually quite easy to find at the moment, because if you go back to our old friend the plough or the saucepan, whatever you want to call it. The saucepan. OK, well, if you think of it as a saucepan, find the handle of the saucepan, follow that round, and if you follow the natural arc of that, it points to Arcturus, that bright orange star.
Lovely star.
So you follow the arc to Arcturus, that's how it's described. And then carry on around that arc, and eventually you come to Spica.
Nice blue-white star.
It is, the brightest star in the constellation of Virgo, and then above and slightly off to the right of Spica, that's where you'll find Saturn.
It's quite a recognisable object. It's sort of a creamy yellow colour.
It definitely has.
And as you say, it doesn't twinkle as much as a star. It's quite easy to
It's actually heading towards another star in Virgo, which has got various names.
Oh,
I call it Porrima. Patrick calls it Arich, but it's known as Gamma Virginis.
I prefer Postvarta, actually. That's quite
a nice name.
Yeah, I quite like that name. Planets feature quite a lot in the news notes this month, don't we? We've got a massing of them. And before we tell everybody where they are, could you give me the nice official definition of massing?
If I can remember it properly, a massing is where you have 3 or more planets together, or 2 planets and the moon.
Is it?
It's not a term which is used very often.
It just sounds so arbitrary.
But the highlights really, it begins at the beginning of the month. So the 1st and the 2nd of May, you've got nice bright Venus, which is going to be pretty obvious, and then Jupiter much closer to where the sun will come up above the horizon. I should say as well, you should never try and find these planets with naked eye or binoculars if the sun is above the horizon. So always do it before sunrise.
Is the crescent moon nearby as well?
The crescent moon is very close by right at the very beginning of the month. And then the next highlight occurs towards the 9th through to the 11th, when Jupiter and Venus actually move very close to each other.
So that'd be quite a prominent thing.
It'll be an amazing thing to see, because Jupiter and Venus will be about 3/4 of a degree apart.
Yeah, that's quite close.
Like a really bright double star in the sunrise, dawn sky. And then right at the very end of the month,
The crescent moon comes back again.
it comes way back in, and you've got the planets there as well. So it should be quite a beautiful thing to see.
And on the subject of images, Pete, we have a nice Flickr group people can upload their images to.
Oh, that's right, yes, the Sky at Night Flickr group, and it's quite easy to find. All you have to do is go onto the Sky at Night website, which is at bbc.co.uk/Sky at Night, and there you'll find a link to the Flickr group. So if you've taken a photograph, you can upload it onto that group.
And we were going through them earlier. Why don't you tell everyone what your favourite one is?
Right, okay.
I know what it is.
Well,
It's obvious what it's going to be as soon as they popped up.
I've gone for a rather lovely photograph of a noctilucent cloud display. And this is taken by Martin McKenna from Northern Ireland.
It's a lovely picture, this.
It's very timely because as we get towards the end of May and into June, that's noctilucent cloud season. These are really high altitude clouds which can be illuminated by the sun when the sun is below the horizon.
The other thing that caught my eye as we were going through them was a lunar crater, one of my favourite lunar craters actually, Clavius.
Ah, that's a fantastic crater.
And this image by Mick Hyde I thought was particularly lovely. I love the little ring of craters on the crater floor of Clavius.
Well, actually, that's actually a test for imaging because those craters get smaller and smaller and smaller. They go almost round.
They do go like an arc, yeah, it's very pretty.
And it's sort of a test to see how good your resolution is and how accurate your images are.
And finally, a picture that caught our producer's eye, M101 in Ursa Major. This is a lovely galaxy, very lopsided, very strange looking.
It's quite a tricky galaxy to photograph well, and this photograph taken by Anna Morris from Suffolk is absolutely superb, actually.
It is. I love the structure in it, actually. It's a very hard galaxy to pick up visually as well, so I think the photograph really does it some credit here.
Well, coming back to the planets, I'm struggling here to get a good view with the poor seeing that we've got.
There, is there?
But indoors, Patrick's talking to one of the great amateur planetary imagers, Anthony Wesley, who's come over all the way from Australia, and he's had some better success than I'm having tonight.
Welcome, Anthony, from the other side of the world.
Thank you, Patrick. Pleasure to be here.
First of all, where do you live, and please, what's your observatory?
I live in a small country town just north of Canberra, the capital city of Australia, and I have a small observatory there in my backyard.
Recently, you've made some very interesting discoveries about Jupiter. Can you tell us about that?
Well, I was lucky enough in 2009 to be the first person to see the impact mark on Jupiter from what's now believed to have been an asteroid. Unfortunately, the impact happened on the night side of Jupiter, so we didn't get a chance to see it, but yeah, it was very exciting.
What did you actually see?
Well, I saw a black spot that looked very much like a moon shadow. It's exactly what you would expect to see if one of the moons was casting a shadow on the planet, except that it was in completely the wrong place. It was down near the South Pole, and it took quite a while for me to realise that it was something quite extraordinary. That's one night, where I felt like I should be in two places at once.
Quite.
The first thought in my mind, in fact, was that maybe this was in several fragments, the same as Schumacher-Levy 9, and so any moment now there might be another impact. And even though the first one happened around on the dark side where we couldn't see it, there was a chance maybe I should keep recording images in case there was anything more.
You say an asteroid. Well, what effects did it have?
Well, the main effect that we could see was that this tremendous impact cloud of debris that was almost the size of the Earth near Jupiter's south pole. It was just a large, dark cloud of soot and ash that was left over from the impact.
How did the mark change as you watched it?
Well, it didn't take very long. Over a period of a few days, it started to elongate, and as the winds on Jupiter blew all this material out off to the side, it was really quite fascinating to see how the high-altitude winds on Jupiter were dispersing this dark material, this dark soot and ash, and it was visible for several months after the fact.
Well, I congratulate you. He's doing a wonderful job, Anthony.
Thank you. I hope so. Thank you, Patrick.
Now, we've been talking about storms on the planets. We also have storms on the sun, and one of these has been in progress quite recently. Now, these solar storms are liable to produce displays of aurorae, or northern lights. And Pete Lawrence went to North Norway to see whether he could see any of these aurorae.
The aurora borealis, known as the Northern Lights, is one of nature's most spectacular cosmic shows. It's caused by the interaction of charged particles coming from the sun interacting with the Earth's magnetic field. I have photographed them several times and they still manage to take my breath away. Northern Norway is one of the best locations to see the aurora borealis. The locals are making the most of it. The old military airfield here is now Snowman International and open to visitors. With me is amateur astronomer Jon Culshaw and solar scientist Dr. Lucie Green.
Wow.
Neither has properly seen the Northern Lights before. Both have high hopes.
Merry Christmas, everybody. So happy to be here with you guys.
This is amazing.
First international people at Snowman Airport.
So it used to be called Bardufoss, but perhaps that sounded a bit too much like Barbados and will be confusing.
I don't think you confuse this with Barbados. could
No.
you? No.
But then, yes, so it's actually Snowman
This is astonishing,
Airport.
isn't it, eh?
We don't want the snow, do we? Because we want to see the stars.
I think
Yes.
it's just putting this on for us now, and then later on
Yeah.
tonight it's going to clear, and we're going
So if
to
all the
see
snow
aurora.
falls out of the sky now, that will lead us with
Good.
clarity.
That's a good
theory.
Yes,
Yeah.
that's my theory. Well, let's declare this airport officially open. The band is over there. Let's do some body popping or something.
What we didn't expect to find was the Royal Navy serving reindeer soup. They use this part of Norway for their Arctic training. Looks like John needs some Arctic training too.
What brings you to Norway? Oh dear. You're right. Sorry, I just fell into the selection of cold meat there. Sorry.
They may be far from home, but the Northern Lights are a familiar sight.
If we can see that tonight.
You do see it more of a lighter green than it is like that is there, but you will usually do see it some. Yeah.
How often would you see a display to that degree?
Oh, I think there's no clouds.
Yeah.
The weather is changeable and there is a large full moon tonight, the so-called supermoon. I'm worried that might wipe out the aurora.
What do you think our chances are then, Pete?
Well, I don't think you can ever say it's any better than 50-50, can you? Because there are so many things that have got to come together so that you can actually see the lights.
My betting is that we'll see a diffuse haze, but we won't see a breakout of a strong show of the aurora. That's my prediction.
OK, so I think we all ought to have predictions, actually. What do you think, then?
Well, I'm going to be quite optimistic. The way this sky is clearing, I mean, I'm looking forward to seeing that so-called supermoon anyway.
Yeah, that's
even
gonna
if
be
we see
great.
nothing else, that'll be great. But also, I've never really seen the Northern Lights before. There was one time I was in Luosto in Finnish Lapland, and there was just a faint sort of something very dark green.
Right,
and-
OK. What about you, Lucy? Have you ever seen them?
I attempted to see them from a flight, and we did see a green haze in the distance, but
Right.
what I really want is to be able to stand underneath and see shimmering curtains of light moving above me.
It's absolutely magical.
And that sun over there. I appear to have... hello.
Oh, that suits you, King
does.
John.
Yes. My name is Maximus Decimus Meridius. I command the aurora to appear.
220 miles into the Arctic Circle, these mountains are ideal for aurora chasing. Access is by skidoo only, so it's a rather hair-raising ride. We battle through a blizzard with our driver navigating the precarious path between snowdrifts and rocks. The snowstorm clears as rapidly as it engulfed us, and we are able to pick our spot for tonight. Mirfell Mountain is 560 metres high and well away from any light pollution.
I can't think of a more inspiring place to watch out for the aurora, hopefully, later on tonight. But what are the scientific and astronomical reasons as to why this, at the top of this mountain, will be such a good spot to watch out for the aurora?
Well, this mountain range is ideally placed for us underneath the auroral oval, so we should see something tonight, even if the aurora aren't particularly strong.
The auroral oval, I take it that's not a cricket ground.
No,
although it
so
sounds like it a bit.
It's the faint haze of the aurora that forms an oval. I mean, in fact, around the North Pole and the South Pole, but
Those
tonight.
are the North and South magnetic poles, aren't they?
That's right.
Yeah.
That's right. Yeah. So you see these lights forming this sort of oval shape, and actually I've got an elastic band here to try and sort of
Oh, yes, wondered what that was
show
for.
why this happens. Yes, it's not for my hair. So I want you to imagine that we've got this constant flow of magnetic field coming from the sun, which is what happens in the form of the solar wind and in the form of something called a coronal mass ejection. So they carry the sun's magnetic field out 150 million kilometres through space to the Earth. But the Earth has its own magnetic field, and that's what I want to illustrate with this elastic band. So if you imagine that my hand is the Earth, you've got a North Pole and a South Pole, and you've got magnetic field lines. Let's just consider one side of the Earth for now. So we've got the sun over here blowing its magnetic field towards us, and it's interacting with the Earth's magnetic fields under some certain special conditions. And under these special conditions, the Earth's magnetic field on the night side gets built up, and it gets stronger and it gets stronger, and it gets more energy put into it. And that's why I'm stretching out my elastic band, because I'm putting energy into my elastic band. So when the solar wind coming from the sun and the magnetic configuration is correct, it sort of charges up the Earth's magnetic field. You could think about it that way. And it puts energy into it. And at some point, it wants to ping back. And then all that energy comes towards the Earth in the form of also charged particles. And they come and they dump themselves into the Earth's atmosphere in the polar regions, because that's where my magnetic field lines
So all the
are coming
magnetic
into
field
the Earth.
lines are actually channeled down in a ring around the north and south magnetic
That's right.
poles, and that's why we get that aurora.
That's right, yeah. And as these field lines ping in, they bring charged particles with them, and they energise the gases in the atmosphere as they come down the field lines and cause them to glow. Just the same way as if you had a neon tube and you passed a current through it, because of course charged particles moving are a current.
So it's the atoms in our atmosphere which actually give the characteristic colours of the aurora as well, and the predominant colour is green, which is due to oxygen.
That's right, yeah, oxygen. So, you know, the stuff we breathe in every day. So you can look at the colour and work out what the gases are that are giving off these colours. It's very beautiful.
I love that. Do the elastic band, that's the magnetic field, and it's got energy in it, and then it goes twang, and everything's green after that. Brilliant.
Our skidoo driver takes us up to the top of the mountain. It's nearing sunset and looks magnificent, but the outlook is still uncertain.
We've been driving around for ages and we still haven't seen any reindeer yet.
Well, we haven't. But at the same time, I suppose, at the moment, we probably don't just care. Because look at this.
It is stunning, isn't it?
That's absolutely amazing. Just to see the sun drop behind the mountains there. The most incredible sunset I've ever seen. Absolutely amazing.
The Samis are the native Norwegians, and they have many folk stories about the aurora. Some believe the lights were the lost souls of unmarried maidens. We are invited into the lavo, or tent, of Johan Oskal to find out more.
Hi.
Hi there, Johan. Great to meet you.
Good morning, Zach.
Thank you for having us.
Very nice to meet you.
Yeah. The northern lights, the aurora borealis.
Do you have any legends? Because I know that if you're supposed to whistle at it, isn't that a problem?
Yeah. So we Sami have we cheating,
like teasing.
Yeah, teasing.
right.
Yeah, teasing. Yeah.
So encouraging it to come
Yeah,
out.
like teasing. Yeah. And if you tease the northern light, then we'll come and get you.
Okay.
So, yeah.
So can you tell us what it is we need to say to encourage the lights to come out?
T.
T, T, T.
Us.
T, T, T.
Close us.
And that will make the northern lights
That
appear.
will make them come.
That will make them come to get us.
Yes.
It's midnight, and we are up on the hill, still hoping for the northern lights to perform. The moon behind us is exceptionally bright. We can barely see the stars, even in this dark sight. Suddenly, the clouds part and a vibrant display erupts. With my camera, I quickly get some pictures. The moon is so bright, the long exposures make it look like day. The display soon settles down to a gentle glow.
There's a little faint display just.
There is. It's starting to
Coming
get
through
bright
there.
over in that
Yes,
patch,
you
isn't
can
it?
see that. Yeah.
We've been spoiled really tonight to see the aurora across in this direction, like that as we've been watching, and then you turn around in this direction, and there's that magnificent,
It's a
majestic full
astonishing
moon.
view, isn't it? We've got the mountains
With the
underneath.
mountains.
That's just absolutely gorgeous.
As quickly as it came, the aurora borealis is gone again. The aurora never fails to amaze. In this speeded up film, we can see the curtains of light moving and shimmering, particles tracing out the Earth's magnetic fields. It's astounding that this magical display in the Earth's atmosphere is caused by activity on the Sun, 93 million miles away.
So what are we seeing when all that's going on?
Right, well, I have to say, I had to kind of pull myself together to look at it because this is the first time I've seen it from the ground, and it really does take your breath away. I can't believe how fast things change. But what we're seeing, essentially, is gases in the Earth's atmosphere being excited by charged particles, and these gases then give off light. And actually what we're looking at is the oxygen atoms giving off light. But the story really ultimately goes back to the sun. So we have to trace through the solar system 150 million kilometres away. And that's where these charged particles and the energy is ultimately coming from.
So
it's going off again, look.
Yes, it is, just there.
Yes, isn't it gorgeous?
Aurora displays are always different and always unexpected, and this one was no exception. For a brief moment, we were all startled and enthralled, leaving us all relieved and glad we made the long trip up to the frozen north.
It's been wonderful to see our very own aurora tonight for the first time for the two of us, isn't it?
It's really a privilege to be here with somebody that's not seen it before, just to see it live, because it is so stunning.
We're just standing
just
there
breathtaking.
like that.
Yeah.
Really quite agog, forgetting how freezing we were. And it rather reminds me of Patrick's description of a lunar eclipse. It's got a quiet beauty all of its own.
Perfect.
Aurorae are glorious things, and I remember seeing them way back in the 1930s. There are always things going on in the sky, and this brings us on to our news notes. This month, over to Chris North.
Astronomers have made a startling discovery. Pluto has an enormous atmosphere. They found that the atmosphere extends for 3,000 kilometres, around a quarter of the way to Pluto's largest moon, Charon. It's hard to believe that tiny Pluto could hold on to such a vast expanse of gas, and there's now evidence that the atmosphere is changing as it makes its long orbit around the Sun. Earlier, we were talking about Saturn and aurorae, and the Cassini spacecraft has seen many of these whilst going around the gas giant. But this latest image shows the aurorae along with something slightly different, a faint auroral spot travelling around the poles of the planet. It seems that this spot is caused by a link between Saturn and the tiny active moon Enceladus, which is spraying jets of salty water into space from fissures at its south pole. And finally, much further afield, to Tycho's supernova, the remains of an old white dwarf star which exploded thousands of years ago. Images from the Chandra X-ray telescope show an arc of high-energy X-rays seen to the bottom left of this image. It's thought that when the star exploded, the blast hit a nearby companion star and blew material off its surface. Astronomers now think that the X-ray arc is the resulting shockwave, and it's providing clues as to the cause of the supernova itself.
Chris, thank you very much. When I come back next month, I'll be taking a long, hard look at the lovely constellation of Cygnus the Swan. Until then, good night.
Horizon presents a guide to the space shuttle here on BBC4 this evening. That's coming up in just a few moments. And then at 9, we're delving into the family history of Robert Louis Stevenson, great lighthouse engineers and mechanics of Scotland, for Lighthouse Stevensons.